Hello guys, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So in the last session, we have seen the concepts related to the kinematics. So in today's session, we are continuing the same topic, that is motion, motion in a straight line. So where in lecture 3, we are going to understand the graphs. So the position time graph and the velocity time graph. So our two main goals in today's class are, so first let's find the distance covered in the nth second and then graphs. So the position time graph and velocity time graph. So acceleration time graph, it's not a part of our syllabus, so we are not going to study that acceleration time graph. Just I'll give the introduction to that. Okay, so as usual, for the next 1 hour or 1.5 hours, just be with me, avoid all the disturbances around you guys. So at the end of the lecture, so don't forget to prepare the short notes. So that's very important, right? So hope you guys are following the lectures properly. If you have any doubts, you can comment down. Okay, so I'll see the comments and I'll answer if any query you have. So I'll answer it in the next class. Okay, so but don't create any backlogs. So whenever we upload the lecture, so try to complete it on the day itself. Okay, so don't postpone it to so the next day, the other next day. So don't do that. Okay, chalo. So let's start with the first one, the distance covered in the nth second. So first, till now we know the distance covered in some time, right? S is equals to ut plus half at square. So this S is equals to ut plus half at square. It gives, so the distance covered in some t seconds. Let's suppose in 10 seconds how much distance the body has covered. So then in place of t you substitute 10, or else in 20 seconds how much distance the body has covered. So then you substitute 20 in place of t. So this is fine, but I need how much distance an object has traveled in a particular second. So for example, so the body has started its journey from here. Let's suppose the body has started its journey from here. Let's take, so this is a 0th second. So in 1 second, so the body has moved till here. So in 2 seconds, so the body is here. So in 3 seconds, let the body be here, and then it continues its journey. So now the distance traveled in the 3 seconds, if I say, so this is the distance traveled in the first second. This is the distance traveled in the second second. This is the distance traveled in the third second. So if I say the distance traveled in the 3 seconds, so then what will you do? So you simply, u is equal, let's suppose body has started from rest, u is equals to 0. So let's suppose some acceleration is given, and then the time will be equals to 3 seconds. You will substitute it in the S is equals to ut plus half at square formula. But the thing is, so what if I ask you, what is the distance traveled by the body in second? So what is the distance traveled by the body in the second? Only in this particular second, how much distance the body has traveled, or else, so how much distance the body has traveled in the third second. In a particular second, we are talking about the distance covered in nth second, particular second, not in n seconds. Understanding the concept? So now, how do we get that? So just think logically, in the general way, think logically. Let's suppose if I have to get the distance traveled in third second, I have to find. So first what I'll do is, if I know the initial velocity and acceleration, so I can easily find the distance traveled in 3 seconds. This is a distance traveled in 3 seconds, right? So now, so if I know the initial velocity and acceleration, let's suppose body is moving with the uniform acceleration. Whatever the conditions that we are seeing are the completely the uniform acceleration conditions. Okay, so now see here. So if the body's initial velocity is known, acceleration is known, so then you can also find the distance traveled in 2 seconds. The distance traveled in 2 seconds also you can find. Now I need the distance traveled in third second. So now you got the idea, right? So the distance traveled in the particular third second will be equals to, so shall I say the distance traveled in 3 seconds minus the distance traveled in 2 seconds. How much distance the body has traveled in 3 seconds till here minus, so the distance traveled in 2 seconds. So this total distance minus this. So then I'll get this part only. So this part is nothing but the distance traveled in third second. So that's why the distance traveled in 3 seconds minus the distance traveled in 2 seconds. This 3 means 3 seconds in 3 seconds. This 2 means in 2 seconds. Third means in that particular third second, right? So similarly, let's suppose if we have to find the distance traveled in the fourth second. Let's say the body has traveled, this is fourth second. So the distance traveled in fourth second we need. So then the distance traveled in fourth second will be equals to, so the distance traveled in 4 seconds and then the distance traveled till prior second. So prior second in the sense the distance traveled till third second. Understanding? So then if I need the distance traveled in some 10th second, so then what I will do? The distance traveled in 10 seconds minus the distance traveled in 9 seconds. And then, so like that, if I need the distance traveled in some particular nth second, so I'll do, so the distance traveled in n seconds minus, so it's prior. So prior in the sense the distance traveled till n minus 1 seconds. So if I need 10th second, S10 minus S9. If I need 15th, S15 minus S14. So if I need 20, S20 minus S19. This is a standard procedure to find the distance traveled in particular nth second. So hope this part is clear. Just you got the idea, right? Now, so let's move further. Let's take one simple question, guys. Pause the video and try along with me. Pause the video and try along with me. So what's the question says here? If the distance traveled by the particle is given as a function of time. So what is that? The distance traveled is equals to, so 5t plus 2t square. 5t plus 2t square. So now find the distance traveled in third second. So we need to find the distance traveled in third second, the particular second. Just understand the question properly. In 3 seconds means time t is equals to 3 you can take. But in particular third second only they are asking. What does that mean? Let's suppose the body has started its journey from here. Okay. So then this is 1 second here. So 2 seconds and then 3 seconds. So this is the distance traveled in first second, second second, and this is the distance traveled in third second. So this distance we required. The distance traveled in particular third second we required. How do we get? Just use the formula. So the distance traveled in third second will be equals to distance traveled in 3 seconds minus distance traveled in 2 seconds. Yes or no? So now simply substitute the values. So the distance traveled in 3 seconds, we know the distance as a function of time. So in place of t, you just substitute the 3 value. So 5 into 3 plus 2 into 3 whole square minus the distance traveled in 2 seconds. So which is 5 into 2 plus 2 into 2 whole square. Hope you guys are understanding, right? Sure. So now this is going to be, so 5 into 3 15 plus, so this is 3 square 9, 9 into 2 18. So minus, so this is 10 plus, so 4 into 2 18. So which comes out to be, so 15 plus 18 minus 18. So plus 18 minus 18 cancel. So it's going to be some 15 meters. Option A is the correct one. Understanding? Just the basic understanding. Clear? Chalo. So let's move further. So now let's derive the formula for distance covered in the nth second under uniform acceleration. So that means the acceleration is, if it is constant, what is the formula for the distance covered by the body in the nth second? So let's say the body has started its journey from here. So considering the initial velocity of the body, here is the object is there, some object. So let's say some Mercedes Benz car is here. So in this Mercedes Benz, so let's suppose the Chintu is sitting here. Okay. So now Chintu is driving this vehicle with an initial velocity u. Okay. So then the uniform acceleration, let it be a. So he is covering some distance s. Is covering some distance s. So in some particular n seconds. So now what is the distance covered in particular nth second I required? So what's the formula that we know in the particular nth second means? So Sn minus 1. This is a general formula. Now I need this in terms of acceleration and initial velocity u. So then what we do? So simply Sn, the distance covered in n seconds. So you know that S formula is ut plus half at square. Just understand carefully. Ut plus half at square. So in n seconds means, shall I write in place of t, simply substitute n. Un plus half an square. Un plus half an square. Right? In place of t, we substituted n. So similarly, minus. So Sn minus 1. So in place of t, you substitute n minus 1. So u into n minus 1 plus half a into n minus 1 whole square. N minus 1 whole square. So now just do the calculations carefully, guys. So un plus half an square. So then this is minus, so substitute inside, multiply minus inside. So minus un, right? So this is minus u, minus half minus u plus u. So then this is going to be minus half a into n minus 1 whole square. So let it be. So here I could see that the plus un minus un gets cancelled. So then let's do the calculation again. So let's rub this part. So we already know that formula. So now I am writing. So let's write this u at the starting. U plus the distance covered in nth second will be equals to u plus, so this is half an square minus half a into n minus 1 whole square. Half a into n minus 1 whole square. So this part is clear till here. Now, so let's do the calculation. So the distance traveled in the nth second will be equals to u plus, I am taking half a, or else simply write this as a by 2. Half into a, half into a. So which is nothing but a by 2. Let's take it as common. So then this is n square minus n minus 1 whole square. N square minus n minus 1 whole square. So then the distance traveled in the nth second will be equals to u plus a by 2. So let's elaborate this one. So n minus 1 whole square, which is n square plus 1 square minus 2n. So then the distance traveled in the nth second will be equals to u plus a by 2. So into n square, let's multiply this minus inside. So minus n square, so minus 1 plus 2n. Right? So n square gets cancelled. So the distance covered in the nth second will be equals to u plus a by 2 into 2n minus 1. U plus a by 2 into 2n minus 1. So this is the formula, guys. Clear? Understood everyone? Chalo. So from now onwards, so the distance covered in the nth second under uniform acceleration. So what's the formula that you should remember, everyone? So just write along with me. So the distance covered in the nth second S nth is equals to u plus a by 2 into 2n minus 1, where u is the initial velocity, a is the acceleration, n is the in which second you have to find the displacement of the body or distance covered of the body. Clear? Chalo. So let's solve some questions. So pause the video and try along with me, guys. Chalo. So the distance traveled by a particle starting from rest. See here, hint. Starting from rest, u is equals to 0. So and moving with an acceleration, the acceleration is constant, which is 4/3 meter per second square. So then, so in the third second, so what they are asking? So the distance traveled in the third second, not in 3 seconds, in the third second. So what is S third they are asking? So now we know that the S nth formula is equals to, so write along with me, you should remember the formula, u plus a by 2 into 2n minus 1. 2n minus 1. So from here we need the distance traveled in the third second. So u, initial velocity is 0, plus a is 4/3 by 2. So then into 2, this is 2 into, in third second we require 2 into 3 minus 1. So now let's substitute. The distance covered in the third second will be equals to, so 4/3 3 into 2, 6. So then this is going to be, so 6 minus 1, 5. So which is nothing but, so 20 by 6. So 20 by 6. So which is nothing but, so 3 2s are, so 2 3s are, and then 2 10s are. So which is nothing but 10 by 3 meters. So option C is the correct one. Clear? Understood? Just substituting it in the formula. That's it. So let's move further. A body starts from rest. So again, see the given information. A body starts from rest, U0. So what is the ratio of the distance traveled by the body during the 4th and 3rd second? 4th and 3rd second, particular second. So what they are saying, the distance traveled, the ratio of distance traveled in 4th second to the 3rd second. So this is this ratio they are asking, right? So we know that Snth formula already. So then S 4th by S 3rd is equals to, so here U plus A by 2 into, so 2n minus 1. So 2 in 4 seconds means 2 into 4 minus 1 by, so this is U plus A by 2 into, so 2 into, so 3rd second. So in place of n substitute 3 minus 1. So now let's see here. So we can write, so the distance traveled in 4th second to the 3rd second will be equals to, this is initial velocity, body is 0, right? Sorry guys. The initial velocity is 0. So plus A by 2 into, so 2n minus 1, 8 minus 1. So which is 7. So then this is 0 plus, again initial velocity is 0. So A by 2, so into, so 6 minus 1, 5. So then I can write A by 2 into 7 in the numerator by A by 2 into 5 in the denominator. So A by 2 cancel. So this is going to be 7 by 5. So this 7 by 5. So the ratio, right? Units gets cancelled. Simply just write 7 by 3. Clear? Understood? Any doubts here till here? So let's move further. So now let's go for the graphs. So hope you guys are clear with the distance covered in the nth second. So distance covered in n seconds is different. Distance covered in nth second is different. Okay? So now, so as a part of our syllabus, so we are going to analyze the different graphs. So which are, the first one, the position time graph. The position time graph. So which is x versus t or s versus t we call it. The position time graph. So which is either s versus t, or so we can also represent it as x versus t, where x is the displacement or position, or s is also the position. Okay, na? In different books they write different denotions. So then, and along with this, we'll also study the different cases of velocity time graph. We'll also study the velocity time graph as well. So where VT graph we call it. So this is a VT graph, velocity versus time graph. So how, if the curve is like this, or curve is straight, or like this, so all these analysis we'll do. So just first, what are the graphs that we are going to study? Position time, so velocity time. So this is VT graph we call, and then this is ST graph or XT graph. Clear? So and acceleration time graph is also there. So we are not going to study much about this. So the acceleration time graph, just I'll give the introduction. So only thing that you have to learn is the area under acceleration time graph will result in the change in velocity. That's it. So this is a AT curve. So let's write it as AT graph. Clear? These two we are going to study in detail. So for different curves. So what if the line is straight? So what if the line is passing through the origin and a straight line, or if it is concave downwards or concave upwards? So all these analysis we'll study now. Clear? So first let's go for the position time graph. The position time graph, S versus T graph. Okay. So let's suppose this is the origin. Okay. So and then body's position is changing with respect to time. Body's position is changing with respect to time, I can say. Let this angle be, always the angle will be measured with respect to the positive axis, guys. So always the angle, the body angle, so this is measured with respect to the positive x-axis. Like this you should take the theta. Now if you observe, we know that the slope of ST graph, results in the velocity. The slope of ST curve will result in the velocity. We already learned this, right? So what is the slope? Slope means the differentiation. So differentiation of what? So ds by s versus t curve, right? So the differentiation of s. So ds by dt, which is equals to the velocity. So similarly, we can write the slope formula. We already know that from the straight lines maths. So slope formula is equals to the tan theta. So from here I can write, so the ds by dt, which is equals to v, which is equals to tan theta. So this is the relation between slope and velocity and ds by dt. This ds by dt is nothing but slope, differentiation of slope and displacement time graph. Displacement time will give the velocity. So differentiation of displacement with respect to time will give the velocity, or we call it as slope of ST curve gives a velocity, or we can also get it from the theta. So now let's say, so I have, this is a displacement time graph of one body. So now I am taking one more body. Let's consider this is another body. So let it be the body 2. So where this body is maintaining some different angle, let it be some theta 2. So let the previous one be theta 1. So now if you observe, we know that the theta 1 is greater than theta 2 here in this particular graph. Just understand carefully. So here theta 1 is greater than theta 2 with respect to positive axis. So the theta 1 is greater than the theta 2, right? So if theta is more, the tan theta will also be more. Tan value increases with if theta increases, right? So then I can say that the tan theta 1 will be greater than tan theta 2. So what is tan theta? Tan theta is nothing but velocity. So I can say that the velocity of the body v1 will be greater than the velocity of the body 2. So v1 will be greater than v2. v1 will be greater than v2. So you can write, so if the more is the slope, the more will be the velocity. So the slope of ST curve, is directly proportional to, let's write this way. So the slope of ST curve is directly proportional to the velocity. If the slope is more, the velocity will be more. If the slope is less, the velocity will be less. So for example, in the exam they give, this is a body P, this is a body Q. So this is making some angle theta 1, so this is making some angle theta 2. So whichever the one is making the theta more, so then the tan theta more. So if the tan theta is more, so the velocity will be more. Clear? So that's why you can simply remember this part. Clear? Understood this part from the position time graph? Sure. So let's move further. Now analyze different graphs. So or else let's see one question, I guess. So let's see one question based on this. So what's the question says? The displacement time graph of two moving particles makes an angles 30 degrees and 45 degrees with the x-axis. So the ratio of their velocities. So they are asking the ratio of their velocities. So see here. So let's consider this is a body 1. So the first one is making 30 degrees. The second one is making 45 degrees. So I can say that theta 1 is equals to 30 degrees. So theta 2 is equals to 45 degrees. So what they are asking? So the ratio of their velocities. So the velocity 1 to the velocity 2. So we know that velocity is directly proportional to tan theta. So here simply we can write the tan theta 1 by tan theta 2. Tan theta 1 by tan theta 2. So what is tan theta 1? So theta 1 is 30 degrees. So by tan theta 2, so which is 45. So tan 45 is 1. So tan 30 is 1 by root 3. So by 1. So which is nothing but 1 by root 3 by 1 is 1 by root 3. So which we can write it as simply 1 is to root 3. So 1 is to root 3. Option D. Hope you guys are already solved this one. Right? Simple one, right? Chalo. So let's move further. So now let's analyze the different graphs of position time graph. So see the conditions. In the first case, I am taking, this is a curve, let's suppose. So let's analyze this graph. This is the origin. So at time t is equals to 0. So the body's position is here. Now at time t is equals to 1 second. So again body is at the same position. Like let's suppose this is some 10 meters. For example, I am saying. So this is at 1 second. The body is still at 10 meter. At 2 seconds, the body is still at 10 meters. At 3 seconds, the body is still at 10 meters. At 4 seconds, the body is still at 10 meters. That means, so the body's position is not changing with respect to time. Here, I can conclude, so the body's position is not changing with respect to time. Is not changing with respect to time. Is not changing with respect to time. So if the body's position is not changing with respect to time, so shall we call it as body is in rest? Body is in rest. So body is in rest means its velocity 0, right? So body is in rest means its velocity 0. Yes or no? So let's suppose at t is equals 0 seconds, I am here. After 10 seconds, I am here. After 20 seconds, I am here. After 30 seconds, I am here. So that means I am in rest with respect to time, right? So the same thing is here. So or else you can analyze this way. So you know that the with respect to x-axis, the theta is 0. It's making an angle. If the line is straight, so the theta is considered as 0. So if the theta is 0, so the tan theta will be equals to 0. So what is tan theta? Slope. Slope is nothing but ds by dt. So the ds by dt is nothing but velocity, which is equals to 0. So you can analyze this way also from the graph. Or else with respect to time you see that. Understanding? Chalo. So let's see the second case. This is the first case. So now let's see the second graph. So let's analyze this. So at time t is equals to 0, body's position is 0. Both are here. So at time t is equals to 1, so body has moved here. At time t is equals to 2, so the body has moved here. So at time t is equals to 3, so the body moved till here. So 4 here. So that means body's position, I can say, so the body's position is changing with respect to time. Body's position is changing with respect to time. Is changing with respect to time. So from here, first conclusion, what you can say? So the body is in motion. Body is in motion. That means body is moving. This is the first conclusion. So now, so whether the body is moving with a constant velocity or accelerating, or the body is accelerating. Okay, so that also we should check. So now further, let's go for the mathematical part. So let's see, this angle is theta. So if I draw the horizontal here, so again the angle theta here, so this one. So if I draw the horizontal here, because we always measure with respect to the x-axis, so that's why I'm shifting this x-axis here. So the angle is going to be theta again. So again I'm shifting this, so the angle is going to be theta. So that's why the theta is constant throughout the body's motion. The body is making with respect to x-axis theta here. Here also theta, here also theta, here also theta, here also theta. So the theta is constant throughout the body's motion. Theta is constant. So if theta is constant, so shall we say the tan theta is constant? So if theta is constant, the tan theta is going to be constant. So if the tan theta is constant, so the ds by dt, tan theta is nothing but ds by dt. So what is this one? Which is velocity. So which is equals to tan theta, which is equals to constant. So that means, so body is moving with a constant velocity. So body is in motion. So in which motion it is? So the body is moving with constant velocity. If the body is moving with constant velocity, we say The body is in uniform motion, right? The body is in uniform motion. The body is covering regular distances in regular intervals of time. In regular intervals, the body is covering regular intervals of time. So that we call it as uniform motion. Hope this part is clear, everyone. Understanding? Chalo. Next. So let's go for the next analysis. So the graph, so here, and one more thing. So here the theta is a acute. Here the theta is a acute. So if the theta is acute, so the tan theta value is going to be positive. Theta less than 90. For less than 90, tan values are going to be positive, right? Tan 30 1 by root 3, tan 45 1, tan 60 root 3. So all these values are acute values are positive. So if theta is acute, tan is going to be positive, right? So that's why, so if tan is positive, so the velocity is going to be positive, uniform motion, and the velocity is positive. So that means, so the particle or the body is moving in a positive direction with a positive velocity. Clear this part? Chal. So now let's analyze the next graph, the third one. The third one. So what I said earlier, so always the theta should be measured with respect to the x-axis. So don't take theta directly, this one. Okay. So the theta should be measured with respect to the x-axis. So this is the theta. Now, so again, if I take at this point, so shift the x-axis. Again, this is going to be theta. Again, this is going to be theta. So the first thing is, throughout its motion, throughout a time t is equals to 0, body is here. T is equals to 1, body is here. So t is equals to 2, body is here. So 3 here, 4 here. So that means body is coming this way. As the time progresses, body is coming this way. Okay now. So then what does it mean? First thing, body is in motion with respect to time. Body's position is changing. So that's why body is in motion. This point is clear. So now come to the next point. So here the theta is the obtuse angle. The theta is obtuse and the theta is constant. If the theta is obtuse and theta is constant. So if theta is obtuse, we know that if theta greater than 90, the tan is going to be negative. The tan is going to be negative. Tan of 90 plus theta. So tan of 90 plus theta comes in the second quadrant. In the second quadrant, tan is negative, right? So for 90, tan will become minus cot, right? Tan of 90 plus theta minus cot theta. So for greater than 90 degrees, so the tan value is going to be negative. So if the tan is negative, so the tan theta here, which is going to be negative, so which is nothing but the velocity, tan theta is nothing but the slope, so which is ds by dt. So here the body's velocity is negative. So the body is moving with a negative velocity here. So and this negative velocity changing or constant? As theta is constant, so body moving with constant velocity. Understand the case properly. So the body is moving with a constant velocity, guys. In the previous one, this one, so the body is moving with constant velocity. But as theta is acute, tan theta value is positive. That's why its velocity is positive. Okay. But here the velocity v is positive here in the previous one. Sorry. Yes. So now, so but in this case, here also theta is constant. Theta is not changing with respect to the position. But the thing is the theta is obtuse here. So which means greater than 90. For greater than 90, so the tan will be negative. So if the tan is negative, the slope is going to be negative, which is nothing but velocity negative. So body is moving with a constant velocity, that is negative constant velocity. Clear? Chalo. So hope you understood now. So let's analyze the fourth curve. So the first thing is body is in motion or rest. At time t is equals to 0, body is here. So at t is equals to 1, body is here. 2 body is here. 3 here. 4 here. 5 here. 6 here. 7 here. So like that, body is in motion. First thing is, the first conclusion, body is in motion. because its position is changing with respect to the time. So that's fine. So now what I am doing is, so to find its velocity is constant or changing, varying. So for that, consider 2 points on the graph. So let's say at this point I am considering, and let's say at this point, let's name this point as P, let's name this point as Q. So at whatever the place you have to find the velocity, so for the position time graph, just draw a tangent there. So this tangent is making theta 1. Now at Q, if you want to find the velocity, so simply, so theta 2. So we could say that the theta 2 is greater than theta 1. Here theta is different, here theta is different. If you take at some other point, so again the theta will be different. So shall we say that the theta 2 is greater than the theta 1? Obviously when you go this side, so the theta values increases, right? So if theta 2 is greater than theta 1, so can we say that the tan theta 2 will be greater than tan theta 1? Tan theta 2 will be greater than tan theta 1. So what is tan theta? The slope. The slope of what? ST curve. Slope of ST curve is nothing but velocity. So can we say the body's velocity at 2 will be greater than the body's velocity is at 1, right? So from here I can say that, so the body velocity, increasing velocity, body is moving with increasing velocity. Whenever there is a change in velocity, can we say that the body accelerating? Can we say that the body is accelerating? Body accelerating. So whether this acceleration is positive or negative, how do we say? So the final velocity is greater than the initial velocity. This is the initial point, let's say this is the final point. So obviously the velocity at Q is greater than the velocity at P. So what is acceleration? V2 minus V1, final velocity minus initial velocity. The final velocity is more, initial velocity is less. So that's why the body is accelerating with the positive acceleration. The body is accelerating with the positive acceleration. Clear? Understood guys, this part? Chal. So now next, let's move to the next curve. So the ST curve, let it be the fifth one, the fifth case analysis. So again the curve is given like this. Let's consider again 2 points. Let it be P, let it be Q. So at P, if you want to find the slope, so let's draw a line. So let it be theta 1, always with respect to the positive x-axis. And then at this point you have to find, so then this is going to be theta 2. So theta this side will be greater. Theta this side will be greater. And as you go this side, the theta gets decreases. The theta gets decreases with respect to the x-axis. This is making the lesser angle. This is more angle, right? So I could say that the theta 2 is less than theta 1. Theta 2 is less than theta 1. So that the tan theta 2 will be less than tan theta 1. Tan theta 2 will be less than tan theta 1. What is tan theta? The velocity. So that's why the velocity at 2 will be less than the velocity at 1. So that means at this point the velocity is more, at this point the velocity is less. So that means body is again in motion. The first thing is body is in motion with respect to time, body is moving. This is fine. Now, so it is not moving with the constant velocity. Body is not moving with the constant velocity. Its velocity changing with respect to the points. Now, so the velocity decreasing. So the body is moving with decreasing velocity. The body is moving with decreasing velocity. So what does it mean by decreasing velocity? So we can say that body is decelerating. Body is decelerating, right? So which means its acceleration is negative, or body is retarding, we say. So this acceleration is negative. Why acceleration negative? So let's consider the velocity at P is V1. So the velocity at Q is V2. So obviously the V1 is greater than V2. So what is acceleration? Final minus initial. V2 minus V1 by T2 minus T1. So here V2 is less, V1 is more. V2 is less, V1 is more. So obviously the acceleration comes out to be negative. The acceleration comes out to be negative. So clear this part guys. So the different graphs. Now, so the easy way that you should remember here, the trick. One trick every student should remember related to the graph. So the trick related to the graph is, so if the slope lines are like this, if the slope lines, the tangents are like this, so slant towards left, slant towards left. If I stand this side, slant towards left, so their slope is considered as positive. Their slope is considered as positive. How, sir? Consider wherever you have to consider. Let's consider the x-axis here. So then this theta is acute, or for this one the theta is acute, for this one the theta is acute, for this one also the theta is acute. So as the theta is acute, the tan theta will be positive. So that's why slope is positive. And for whatever the slope lines, if they are like this, slant towards right, slant towards right. So if you take the x-axis, some random x-axis here, so this angle is going to be the obtuse. So for obtuse angles, the slope is going to be negative. Slope is going to be negative. And whenever the tangents are like this, so the slope 0. The slope 0. Very, 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 very important. Okay. So in the question, if they say the graph is given like this, already we solved one question in the previous sessions, I guess. So this is a point P, this is a point Q, this is a R. So now at which point the velocity is negative? Let's suppose this is a displacement time curve. At which point the velocity is negative, if they say. So what you do? Simply draw the tangent here. So draw the tangent here, draw the tangent here. So this is slant this side, this is also slant this side. These two are positive. This is positive, this is positive. This is slant towards right. So that's why this is negative. At Q, the velocity is negative, we can say. Understanding? Sure. So and then one more trick. This is related to the slope. Now one more trick. So that is, if the displacement time graph, if it is concave upward, so if the ST curve, it is concave upward. If the ST curve, it is concave upward. So then we can say that the body is moving with positive acceleration. The body is accelerating, positive accelerating. And then, so the second is vice versa. So if ST curve, if it is concave downwards, if it is part of a concave downwards, okay, so then, so if the ST curve, it is concave downward, then so we can say the body is decelerating. So it is, let's suppose if it is concave downward, so then its acceleration will be negative. So this trick also you remember. If it is position time graph, if it is concave upward, acceleration positive. If the position time graph, the concave downwards, so the acceleration negative. Clear? Understood everyone? Sure. So let's move further. So let's take one simple question. What's the question says? Figure 1 and 2 show the displacement time graph. So the displacement time, see here x is given. Xt is the displacement time. Here also xt is the displacement time. So moving along the positive x-axis, then we can say that both the particles are having uniformly accelerated motion. So this is, see, this is a position time graph, concave upward. This is a concave upward, whose acceleration will be positive directly, we can say. Whereas, so this is concave downward, part of the concave downward, right? So this is concave downward, whose acceleration is negative. Concave downwards. So whose acceleration will be negative, or we can say it's decelerating or retarding. So here they said both the particles having uniformly accelerated motion. No, not uniformly accelerated. Acceleration changes. So this option is wrong. Both the particles having uniformly retarded motion. This is accelerating, this is retarding. So this is also wrong. So particle 1 is having on uniformly accelerated motion. Yes, body is having the accelerated motion, particle 1. Which particle 2 having an uniformly retarded motion? Yes, particle 2 is having retarded motion. Option C is the correct one. And particle 1 is having uniformly retarded? No, this is uniformly accelerated. So this is accelerating. This is retarding. Understood? Understanding the graph? Right? Chalo. So just note this down. Chalo. So let's take one more question. So the graph. The velocity time graph of a particle moving along the x-axis is given shown in the figure. So the corresponding displacement time graph. This is the conversion they are talking about. See here. So here velocity time graph is given. So we have to find its respective displacement time graph. So understand carefully. First, body's velocity is body is maintaining the constant. Velocity is increasing with respect to time. See here. The velocity is increasing with respect to time. So if the body's velocity is increasing, so we can say here body accelerating. Here body accelerating. If the body's velocity is increasing means, so body is accelerating, right? So if the body accelerates, what is the corresponding displacement time graph? For the positive acceleration, so the corresponding graph is like this, right? And then, so then the velocity, see here, with respect to time, so the velocity decreases. So the velocity is going to be constant, sorry. Velocity is constant and negative. Here, see here, below the x-axis. Velocity is constant and negative. So negative velocity we have the slope versus the displacement time graph like this. Yes or no? So just now we have seen, right? Just understand the graph properly. First here the velocity is increasing with respect to time. At t is equals 0, this is the velocity. At t is equals to 1, this is the velocity. T is equals to 2, this is the velocity. 4, this is the velocity. With respect to time, its velocity increasing. That means body accelerating. Body accelerating. So then for accelerating body, we know the displacement time graph is concave upward, right? Concave upward. So whereas the next part here, the velocity is constant. At time t is equals to, this is the velocity. At this time this is the velocity. At this time also this is the velocity. Velocity is not changing with respect to time. So but this velocity is negative. Velocity negative means, so this is a graph slant like this. So which is, this option is wrong. This is not straight line. So this is concave downward, no. So this is concave upward and then straight. So option D is the correct one. Clear? So this is how you should do the conversion. Next. So now let's go for the velocity time graphs. The same analysis we are going to do. So first we know that, let's suppose this angle is theta. The slope of VT curve will result in acceleration. The slope of VT curve, this we already seen. So the slope of VT curve, velocity time graph, will result in the acceleration. So what is slope of VT curve? So which is dv by dt. So if the angle is theta here, so the slope we call it as tan theta. So which is equals to the acceleration. So the acceleration, this one. So now, so if I take, let's suppose this is theta 1. If I take some other body whose velocity time graph is like this. So let this be theta 2. So as theta 2 is greater than theta 1, so shall we say that the tan theta 2 is greater than tan theta 1? So then can we say that the acceleration at 2 will be greater than acceleration at 1? The acceleration at 2 will be greater than acceleration of the second one is greater than the acceleration of the first one. So that means the acceleration is directly proportional to slope of VT curve. So the acceleration is directly proportional to slope of VT curve. Slope of VT curve. So now you should understand the slope of VT curve will result in the acceleration. Right? This part is clear, I guess. Right. Next. So now let's analyze the different graphs. So let me move bit faster here. So at time t is equals 0, the body's velocity is here. At time t is equals 0, t is equals to 1, the body's velocity is here. So at time t is equals to 1 second, so the velocity is here. So that means the body is moving with a constant velocity. Some velocity is there. So velocity is not 0 here. So the body is moving with constant velocity. Body is moving with constant velocity. With constant velocity. So which we call it as, so the body is in uniform motion. So the body is in uniform motion. The body is in uniform motion. Clear? Chal. So next, so see this part. So the velocity time graph, let this angle be theta. So now at this point also angle is theta, at this point also angle is theta. So then can we say, so here the theta is constant, here the theta is constant, so then the tan theta is going to be constant, theta is constant. And one more thing, the theta is acute. This is also important, the theta is acute. So as theta is constant and theta is acute, so the tan theta is going to be positive and constant. The tan theta is going to be positive and constant. So what is tan theta? So tan theta is nothing but dv by dt, which is equals to tan theta, which is equals to constant and positive. So what is dv by dt? Which is acceleration. So that's why, so the body is having constant acceleration, constant and positive. So this acceleration is positive and constant. Body is moving with uniform acceleration, that is positive. So if they ask what is the displacement time graph for this, what is the respective displacement time graph for that? So you can simply write, so the respective displacement time graph for that is concave upward graph. Understanding? Just relate the things, guys. So acceleration is positive and constant, which is nothing but uniformly accelerated motion we call. The body is in uniformly accelerated motion. Okay. So the uniformly accelerated motion, the slope versus time graph will be, the displacement versus time graph will be concave upward like this. Done? Chalo. So next we have, so the slope is here. So this is theta. So and then again this is theta. So here the theta is constant, but the theta is obtuse. The theta is obtuse. So then shall we say the tan theta will be negative and constant. Tan theta will be negative and constant, right? So then can we say that the acceleration is equals to dv by dt, which is equals to tan theta. So which is negative and constant, which is negative and constant. So that's why here the acceleration is negative and it is constant. The acceleration is negative and constant. So then what we can say, the body is uniformly retarding motion. So the body is in uniformly retarding motion. The body is in uniformly retarded motion. So the body is in uniformly retarded motion. Hope you guys are understanding. So if they ask what is the respective displacement time graph for this, so the respective displacement time graph is concave downward shape. Concave downward shape. Clear? So now let's analyze the another graph. So let it be the third one. So let it be the fourth one. So here velocity versus time graph. Let's consider one point P here. Let's consider one point Q here. So now let's draw a tangent. Let's suppose it's making an angle theta 1. So this is theta 1. So then this is theta 2. Let's suppose this is theta 2. So you could see that the theta 2 is greater than theta 1. Theta 2 is greater than theta 1 and both are positive only. So and then we can say that the tan theta 2 is greater than tan theta 1. So what is tan theta? So the slope of VT curve. So slope of VT curve is nothing but acceleration. So that means acceleration 2 is greater than acceleration 1. So that means body is moving with increasing acceleration. Body is moving with increasing acceleration. Understanding? Chalo. So next. So the fifth. So let's consider the fifth one. So let's take one more. So let's take one more. So let's see here. The VT curve, the fifth case. V versus T curve. So if it is like this. So consider like this. So now let's suppose I am considering a point P here and a point Q here. So then this is a tangent. Let's suppose it is making angle theta1. So then let's suppose this is theta2, which, right? So you know that this side the theta will be more. So that's why the theta2 will be less than the theta1. Theta2 is less than the theta1. So that's why the tan theta2 will be less than tan theta1. That's why tan theta is nothing but the slope of VT curve. So slope of VT curve is nothing but acceleration. A2 will be less than A1. So that means body is moving with decreasing acceleration. Decreasing acceleration. Hope you guys are understanding the graphs now. Right? Clear? Chalo. So let's move further. And coming to the acceleration time graph. So what you can just remember is, so this is the acceleration time graph. So the area under AT curve, will result in change in velocity. Change in velocity. Area under AT curve results in change in velocity. Okay, na? So as a part of this, you can also list down, I can say the slope of, just write this point guys. So the slope of ST curve results in velocity. This point is clear, everyone? And then the slope of VT curve results in acceleration. This is also clear. And then, so the area under VT curve, results in the distance or displacement. Results in distance or displacement. Right? We have already seen this, or else I'll write the equations again. So and then area under AT curve, which is equals to velocity, change in velocity, better, right? The change in velocity. Yes or no? So how, sir? And if you say how, so we know that, so the acceleration, the velocity is equals to the integration of ADT, right? So the acceleration is equals to integration of ADT. So which is nothing but the area under AT curve gives a change in velocity. So or else I'll write everything here. So the displacement to velocity, so to velocity to acceleration. So then what we say, so the slope of ST curve, so which is ds by dt, will result in velocity. That's what I wrote. The slope of ST curve will result in velocity. And the slope of VT curve will result in the slope of VT curve. The slope of VT curve, differentiation is slope. Slope of VT results in acceleration. And similarly, from here to here, so the integration of VDT, what is integration? Area under the curve. The area under VT curve will result in distance or displacement. If the body is moving in the straight line, the distance and displacement both are equal, right? And then, so this side, the integration of ADT, where, so the area under acceleration time curve will result in the velocity. Clear, everyone? Chalo. So list it down. So now while taking this, so as I said earlier, so the area under VT, the area under VT curve or VT graph, so will result in either distance or displacement. Distance or displacement. So now how do we find distance? How do we find displacement? So depending on the given graph. So that's also important, guys. So here the distance is going to be simply add all the areas. So if the graph gives, look at the graph given here. So this is the total graph. So simply add all the areas, A1 plus A2 plus A3. But while doing for the displacement, what you do is, so below the x-axis take the areas as negative, above the x-axis take them as a positive. So that means A1 you should take positive, A2 is below the x-axis, take it as negative, and A3 is again positive. So A1, A2, A3. So these three you should add so that you get the distance. So for the displacement, A1 minus A2 plus A3. So the same for the acceleration time graph also. If you have to find, let's suppose this is acceleration time curve. So these are the velocities V1, V2, V3. So V1 plus V2 minus V2 plus V3 you should do. Clear? Understood this part? Chalo. So now let's solve this question. Simple question. What's the question says here? Try along with me. The velocity time graph of a body moving in a straight line is shown in the figure. Velocity time graph is shown. So the displacement and distance traveled by the body in 6 seconds from here to here. Okay, chalo. So now first thing is, what is the let's say what is area 1? Let it be area 1, let it be area 2, let it be area 3. So area 1, how do you find? So from here to here 2, length is 2, breadth is 4, 2 into 4, 8 meters. So then find area 2. So from here to here it is 2, and from here to here it is also 2. So 2 into 2, 4 meters. And then A3, which is equals to, so 4 to 6, which means 2. So and then this is 2 or 3. So some in between it is given. So I guess 3. So let's take. So we'll match the options. I guess it is 2 or 3. It is in between it is given. So just consider it as 3. So then we'll check the options. Okay. So then let's take the distance, guys. For the distance, simply we have to add all these. So which is nothing but A1 plus A2 plus A3. So which is nothing but 8 plus 4, 12, 12 plus 6. So which is 12 plus 6, 18. So 18 option is nowhere it is there. So just consider it as 2. So consider it as 2. So because this is take up to 2 only. Okay. So then 2 into 2, 4. 4 meters. So then it's going to be 8 plus 4 plus 4. So 8 plus 8, 16 meters. So the distance is, first one what they asked. So the distance, second one, the displacement, find the displacement also. Respectively they said. So the displacement, which is A1 positive you should take, A2 negative you should take, A3 positive you should take. So A1 8, A2 minus 4, A3 plus 4. So minus 4 plus 4 cancel, plus 8 meters. So first write the displacement, then write the distance. Displacement is 8. Displacement is 8. This option is there, this option is there. And distance is 16. Distance 16 is there in this option. Option A is the correct one. Clear? Understood? Chalo, next. So let's take one more question. So the velocity time graph. So the velocity time graph of shown in the figure. So the acceleration. So VT graph is given. Acceleration is what? So acceleration is equals to the change in velocity by change in time. Change in velocity by change in time. Change in time. So what we read? So the acceleration we read. So acceleration is nothing but, so we can say the tan theta, the slope of VT curve. So the acceleration is nothing but the slope of VT curve. So you could see that here you could see that. So the slope is going to be negative. So if the slope is negative, the slope is theta is greater than 90. So the acceleration is going to be negative. So then minus negative tan theta. So what is tan theta here? Opposite. Opposite is 15. Opposite is 15 by adjacent. Adjacent is 3. So minus 15 by 3, which is minus 5 meter per second square. So don't take plus 5. So it's a minus 5 because it's negative acceleration. VT curve, if it is like this, already we have seen. So if the VT curve, where is that? See here. If the VT curve is like this, so the acceleration should be negative, right? So that's all. So the same question here they asked. Done? Chal. Next. So then acceleration time graph. So as we discussed earlier, so if you take the acceleration time graph, so the only thing that you have to remember is the area under acceleration time curve. The area under AT curve will result in the change in velocity. Will result in change in velocity, which is nothing but delta V. That's it. So this is the only part you should remember. Clear? Chal. So let's take one more question. So this is a standard result, you should remember, guys. This is a standard result everyone should remember. So first understand the given question, what they are saying. A train accelerates from rest. So a train, let's suppose this is from where? So u is equals to 0. So the train is accelerating. So rest for time t1 at a constant rate, let's take this as alpha. At a constant rate alpha, acceleration is equals to alpha. So for time t1 it accelerates. So and then it retards. From this point, let's say it starts retarding at a constant rate beta. Let's take not q, let's take this as beta. So then here the acceleration is retarding, so which is minus beta. So then it comes to rest. So finally its velocity has become 0. Its initial velocity is 0. Then it accelerates for some time. For t1 time it's accelerate with an acceleration alpha. So then from that point it retards. Retards means negative acceleration. So a is equals to minus beta, and again it comes to rest. So this time is t2. Okay. So now let me consider this point is A, this point is B, this point is C. Now, so first let me take A to B motion I am considering. A to B motion. So where the initial velocity of the body is 0, the time taken t is equals to t1, and the acceleration a is equals to alpha, right? So then I can say that the let the velocity here it be v. Let the velocity here it be, let it be v dash. So from here shall I write v is equals to u plus at formula can we apply from here to here. So now v, in place of v we have v dash, which is equals to, so u 0 plus a, what is a? Alpha. So then time t. So from here I can write v dash, which is equals to alpha t1. So let the time be t1, from here to here time t1, right? So v dash is equals to alpha t1. So let it be. So now what I am doing is, let's take the motion from B to C. Observe carefully. From B to C. So whatever the velocity it is here, it will become the initial velocity for this journey till here to here. See, body is moving from here to here, it's accelerating, and then from here it is decelerating, from here it is decelerating. So whatever the velocity is there here, it becomes the initial velocity for this journey from here to here. So that's why the initial velocity from B to C will be equals to the final velocity of this, which is v dash, right? Till here it's accelerated, and then this decelerating from here. So that's why this is the initial velocity for this journey, and the time taken from here to here it is t2. So that's already given, and then the acceleration is minus beta. The acceleration is minus beta. So then final velocity v is equals to 0. Again same equation I am applying. V is equals to u plus at, kinematic equation I am using. So the final velocity v 0, u the initial velocity which is v dash, plus acceleration which is minus beta. So time t2. Understand carefully. Now so 0 is equals to, in place of v dash shall I substitute alpha t1? In place of v dash shall I substitute alpha t1, right? Minus beta t2. So from here we can write, send this to this side, alpha t1 is equals to beta t2. So they are asking us to find the ratio of t1 by t2. So therefore t1 by t2 is equals to beta by alpha. So remember this as a standard result, guys. Remember this as a standard result. So a train accelerates, let's suppose any vehicle, it accelerates for some time t1 with an acceleration alpha, and then it retards with an acceleration beta for some time t2, and again it comes to rest. So then the ratio of the time taken from the first one to second one will be equals to, so beta by alpha. So the second case acceleration by the first case acceleration. Understood? Clear? Chal. So interesting, right? Chal. So let's see one more standard result. Let's see one more standard result. So now what's the question says? A car accelerates from rest. A car accelerates from rest. So let's suppose here is a Mercedes Benz we already took, right? So let's take this as RD. So in this RD, the Chintu is sitting. The person Chintu is sitting. So now, so accelerates from rest, u is equals to 0. So at a constant rate alpha, so the acceleration is equals to alpha. So for some time. So then which it decelerates at a constant rate? Beta. So then it decelerates at a constant rate beta. So and comes to rest. So from here it starts decelerating. So at a constant rate beta, decelerating means minus beta. So then it comes to rest. Its a final velocity is becoming 0. Initial velocity 0, final velocity 0. So if the total time elapsed is t, so from here to here, let the time elapsed is t, total time is t. So then the maximum velocity acquired by the car. So they are asking us to find what is the maximum velocity acquired by the car. So first let's suppose the body is accelerated for some time t1. Consider the body is accelerated for some time t1. Then it decelerated. So what will be this time? Total time is t. This time is t1. So this time will be t minus t1. This time will be t minus t1. Now, so just see here. Again same thing I am applying. So first what you have to find? Maximum velocity. First understand where the maximum velocity will be attained. Body starting from rest. Accelerating. Accelerating. Till here it accelerated. From here it is retarding. So wherever it starts retarding, at that point, shall I say the velocity will be maximum. So body is accelerating. Accelerating. So then it starts decelerating. At whatever the moment you stopped, like you are starting the deceleration, so at that point, before that second, so the velocity will be maximum. Yes or no? So here the velocity will be maximum. From there again the velocity decreases and becomes 0. Understood, right? Chalo. So now the same as previous question. So I am considering first A to B motion. Let's consider this as A point. Let's consider this as B point. Let's consider this as C point. So let's consider A to B motion. So let's write the equations. So the initial velocity is 0. The initial velocity is 0. So and then time t is equals to t1. The acceleration a is equals to alpha. Right? So then, so I am using the equation v is equals to u plus at. So from here the v is, let it be the v max at that point, or else let's consider this as some v dash. So that v dash is equals to v max. So v dash is equals to initial velocity 0. So acceleration alpha t1. So v dash is equals to alpha t1. So let it be. This is same as of the previous one. So now let's consider the motion from B to C. Let's consider the motion from B to C. So from here the initial velocity will be equals to the final velocity of the previous one. So which is v dash, same as of the previous one. U here is equals to v dash. For this journey, its final velocity will become the initial velocity, and then in this journey the final velocity is 0. So the time taken t is equals to, let the time taken t2 is equals to t minus t1 here. So the time taken from here is t minus t1, and then what else they gave? The acceleration a is equals to minus beta. So let me do it in the next page. So then let me use the same equation, v is equals to u plus at. So the v is nothing but 0. The final velocity is 0. So initial velocity v dash, acceleration minus beta. So time taken t minus t1. So t minus t1. Now, so I can write 0 is equals to v dash minus beta into t minus t1. So right. So from here v dash is equals to beta into t minus t1. So what we can write in place of beta? So what we can write in place of beta? Sorry, v dash. V dash place we can write alpha t1, which is equals to beta into t minus t1. So beta into t minus t1. So but what we actually required? So what we actually required? We required, so the v max. So what is v max? V max is equals to alpha t1. V max is equals to alpha t1. Sorry guys, see some mistake we did here. So v is equals to u plus at. So v dash, which is alpha t1, so which is minus beta into t minus t1. So fine. So this is alpha T1 is equals to, so beta T minus beta T1. So beta T minus beta T1. So from here, so shall I write, so alpha T1 plus beta T1 is equals to beta T. Some mistake we did, just check once. First the body has started from rest, so time t is equals to T1, A is equals to alpha, so then V is equals to U plus AT. Initial velocity 0, so V dash is equals to alpha T1. This is fine. So then initial velocity U is equals to V dash. So U is equals to V dash, fine. So then V is equals to 0, acceleration is equals to minus beta. So the total time will be T minus T1. So T minus T1, fine. So next. So from here, let's write the equation. Let's write, see, check the options once. So here we don't have any T1 term. Here we don't have any T1 term. So we need completely in terms of V dash, right? So let me write. So from here, so the T1 is equals to V dash by alpha. So T1 is equals to V dash by alpha. So let it be. So now I'm using the equation V is equals to U plus AT. So from here, let's write V, final velocity 0. So the initial velocity. So here the initial velocity is V dash. So V dash minus A, which is beta. So I'm writing A is equals to minus beta. So from here T into T minus 1. T into T minus 1. So now see here. So from here V dash is equals to beta into T minus beta T1 minus. So this one, so you sent it to this side, right? So beta T minus beta T1. So from here, so V dash is equals to beta T minus, let's eliminate this theta 1. So what is theta 1? T1. So T1 is equals to V1 V dash by alpha. V dash by alpha. So from here I can write V dash is equals to beta T minus beta V dash by alpha. So we need the V dash. So let's bring this term to this side. V dash plus beta V dash by alpha is equals to beta T. So let's do one thing. So from here what I am doing is, let's write, so V dash common. So which is 1 plus, so here 1 plus beta by alpha. So which is equals to beta T. So then I can write this V dash as alpha is a LCM. So then alpha plus beta, so which is beta T. So then V dash is equals to, so send this to that side, alpha beta T by alpha plus beta. So this V dash is a maximum velocity, yes or no? This V dash is a maximum velocity. So that's what they are asking. So therefore the maximum velocity, will be equals to, so alpha beta T by alpha plus beta, or alpha beta by alpha plus beta into time t we can write. So the option alpha beta by alpha plus beta into time t, option D is the correct one. Clear? Understood everyone this part? So this is also one of the standard result that you should remember. Okay, previous year NEET and JEE we got questions based on this concept. So direct questions. Okay, clear? So chalo guys, so that's it from my end in today's session. So we'll meet in the next class with the concept of motion under gravity. Okay, so till then keep studying. All the very best. Bye. Take care.